Hello, welcome to the ninth design pattern and frameworks session. So today we are looking at another design pattern, another behavioral design pattern. If you look at our journey so far, so uh, we have divided the design patterns into three types: creational, structural, and behavioral. In creational design pattern, we looked at two design pattern, singleton factory design pattern. Last week during our in-class discussion, we went to the singleton design pattern as well. We just had a visit to the singleton design pattern through a in-class quiz. Then structural design pattern, we have already taken for the four design patterns: adapter, decorator, facade, and proxy. Last week, we started our first behavioral design pattern, which is template. And then today, we are looking at a very simple, thus very important design pattern, chain of responsibility design pattern. Before we move into the discussions of this chain of responsibility design pattern, let's look at a scenario. Let's say you are going for a doctor, going to see a doctor. Obviously, you are going to see a doctor when you have some illness. So you go to the doctor, you get the medicines from him. Sometimes, first and first time, sometimes doctor might not give you any medicines. He or she will refer you to some other doctor. So you go to that doctor, referred doctor, and you get the medicines from him or her, but that doesn't solve your problem. That doesn't solve your illness. You go to another doctor. So you go in this chain until you get a proper response, a solution. So chain of responsibility is something similar, the design pattern where we have actions until you get a solution, you get through this chain. So it's behavioral design pattern, and basically it's avoid coupling sending a request to receivers by giving more than one object. So you don't send requests to many objects at once. You go one after the other, one after the other. So a chain the receiving objects and pass the request along the chain until the object handles it. Until someone handles it, you go through this chain. Classical example is consulting a doctor. The processing chain may end in two ways. It can end in two ways. Obvious way is either the process the handle this completely. So you handle the solution, you provide the solution. So you don't need to go through the rest of the chain. Second one is a little the problematic incident, that is you have reached the end of the chain. You have not got a solution, but you have hit the end of the chain. So this is how it happens. You get a request and then you send it to the handler one and then to the subsequent handler. If you don't get a request again, you send it to the next handler until you uh, get the solution or until you hit the end of the chain. So another very good example for this is exceptions. If you remember exceptions, that is, okay, first you handle one exception. If that doesn't handle, you go to another exception. If that doesn't handle, it goes to another exceptions. Now just imagine two things can happen. One is either one of your exception will handle the error, or you have gone through all the exception handlers, but still you haven't received your it was not able to handle your exception. So probably then at that time you will experience a crash of your piece of code. So this is the very simple architecture. Clients and a handler, there will be a handler which is typically an interface from that interface, there can be many concrete handlers. In some situations, there can be situations where you can add handlers little later. At the design time, you will have few handlers at the first design time. Depending on the customer's improvements, customer requirement changes, you will add different handlers. Right. So this is another example from C# Perl. So you will see this is a receiver. The someone is sending a message, and it will be handled by the email handler or the fax error handler. So this is a message. It will be sent through the issue raiser. So there is an interface, and these two classes are implements through receiver. And remember, depending on the message, so this is not only that, this has some additional situations where it has some the message priorities as well. You can define what the priorities for the messages. Depending on the priority, this chain can differ. Okay, so what are the possible applications for chain of responsibility? Spam detectors. Now, how do you handle the spam detectors? If you look at spam detectors, there can be different logics. First, you look at the sender. If the sender is blacklisted sender, you detect it as a spam. If not, you go to the next step. You check the content. If the content is okay, you look at the size of the email. So likewise, you go through each and every step, and then finally, uh, if you received, if any of these handlers will identify this as a spam mail, you will detect this as a spam. If not, if you go through the entire chain, then you will say that, okay, this is not a spam mail, this is a normal email. Medical testing, which we discussed just now. You go through each step by step. You look at the next recommendation from the doctor. You take those recommendations. If not, you go to the next doctor. So likewise, you go by each handler. Troubleshooting. So let's say you have in application troubleshooting. How do you handle troubleshooting? First, you check your application side. If the application side does not work, you go for the databases. If the database is also fine, then you go to the network issues. If not, then you go to the storage, hardware. So likewise, you will have different steps. So troubleshooting is another very good example for chain of responsibility design pattern. Classifier systems. Now there are multi-classifiers where you go through each and every classifier and get the better answer. Since you have not done classifier part of your AI, I'm not going to the details of this. Classifier system is also another very good example for chain of responsibility. Event handling frameworks. Now, if you want to handle an event, right, the good example is exception handling. That's an event. So event handling frameworks can handle this uh, chain of responsibility design patterns. If you remember the things we discussed in last semester, event-driven programming has three concepts. One is generation, detection, and reaction. So how do you react? For a given generated events, you can have different types of reactions. So this reaction is a chain of responsibility design pattern. Security systems. In some security systems, for example, authorization, you need to go for different layers. First, you check the authentication. If the authentication is successful, you go to the next layer. You look at whether he has a permission to the database level. So then you check whether he has the database access to the table level. Then the particular record. Likewise, you can go into each and every step and find out whether you have correct permissions. Okay. One of the important thing is setting up the priorities. Now you have multiple handlers. If I go back here, so you have multiple handlers, and these handlers go one after the other. So therefore, placing these handlers are also very important. Who will become first handler? Who is the next handler? Now in example, if you look at this one, there are two handlers, email and fax email error handler and the fax error handler. Now, in your chain, how do you prioritize these two handlers, which is very important uh, in this chain of responsibility design patterns. So there are three things that you need to consider. First, one of them is performance. Now just imagine you have multiple handlers and the first handler is taking lot of time to process, which means all your requests needs to take a lot of time for the first handler to complete its task. So therefore, typically you check your first handler or the early handler should be processed as quickly as possible. Then the accuracy. Early handlers should have higher accuracy than the rest handlers or the end handlers. Then the complexity also should be very less for the early handlers. So when you are setting up this priority, these three parameters are very important. Don't think that everyone will treat it equally when it comes to these handlers, right? So what are the advantage of using the chain of responsibility design pattern? Now, good thing is you have one no more object to handle a request. You have a chain of responsibilities. So there are multiple objects that multiple handlers can handle your objects. And another important thing is these handlers need not to be static. Depending on the scenario, you can add the new handlers, or else with the prior knowledge, you can skip some handlers. If you know for a fact that if the first handler give you some output, then you don't need to run for the second handler. You can skip the second handler, go to the third handler. Also, you have the option of shuffling the handlers. Depending on the request, you don't have to follow the handler 1, handler A, B, C always. You can change it depending on the previous knowledge that you can, the previous knowledge with this particular environment. Ideally, these handlers are working individually, independently. So they need to know what the next handler does. So basically they are independent. Sometimes they are the loosely coupled. There are some relationships, but it can handle its own and pass the object to the next handler if he can't solve it out. In this design pattern, you are decoupling the senders and the receivers. So you are sending it and there is a receiver. You have decoupled those. Instead, there are handlers in between for you to handle these events. Then, very important thing is high availability and disaster recovery. So what is high availability? When it comes to high availability, that means you are providing the continuity of business. You are continuing your business even if there is a issue of giving the services. So when you have multiple handlers, you can replicate your handler. That means same handler will be doing its task by another handler. So when you have replicated handlers, in case one handler fails, other handler will take over the job. That's a high availability. High availability, normally we talk for a given set of time. Disaster recovery. In case one handler crashed, in case another handler is not spinning it up, so you can use another handler to take over that job. So it's not only the work as normal. In case of high availability, as well as in disaster recovery, we can use uh, this chain of responsibility design pattern. Then what are the challenges? One of the major challenges in this method, there is no guarantee that the request will handle uh, perfectly, because it might reach the end of the chain but it may not have handled the request. So typically what we do that in that type of a scenario is we will have a default handler. But this is very good in exception handling. If you remember exception handling, what we do is we will have a let's say for example, we look at the database exception, then we look at the file exception. So likewise, and finally we have the common exception, which is the default handler. In case all the exceptions couldn't handle this, you have a default handler and you're pretty much sure everything will be handled by the default handler. And when you have this type of dynamic handlers, sometimes these are uh, changing their order, sometimes they are skipping depending on the request. So debugging become little tricky when you are using this kind of design. And also, if you have unnecessary handlers in your chain, that might have an impact on the performance of your system. That is, now let's say you have 5 handlers, given request handled by the late handlers, fourth or fifth handlers. So what has happened is it has gone through unnecessarily in the first 3 handlers. So by doing that, you are unnecessarily loading the systems with running this the handler 1, 2, and 3. So in that type of a situation, you can set the priority. Okay, you can say, okay, for this type of handlers, this type of the objects, these are the important handlers that you can do, and then you can bypass the handlers as well. So again, remember, even the chain of responsibility is a very simple design. You can improve the efficiency of this by setting up the priority as well as setting up the setting up the bypassing mechanism on the information that you received. Uh, Typically, when you are running in chain of responsibility design pattern, you will have a knowledge base or ontology with this. Now just imagine if you have a spam filter. With the spam filter, what they do is they time to time they update their database. Database is their ontology, knowledge base. So with this ontology, they improve their performance of their handlers over the time. I'm not saying daily basis. Over the time, they look at the events, how it was handled, and they will have a sort of auditing. Using that information, they will improve the handlers' precision, priority, bypassing. Everything can be improved using those information. Again, so we will have 3 reflective questions in order to discuss this during the class. How does the chain of responsibility pattern promote flexibility in assigning responsibilities among objects, and what trade-offs might it introduce? In what real-world software scenarios could the chain of responsibility more effective than using conditional statements? So rather than using if and else statement, how chain of responsibility is more effective? Think about the large-scale applications in this particular scenario. How might an improper implementation of chain of responsibility lead to performance issues? I just said, right? How in case you have a improper implementation of chain of responsibility, how can you have improper implementation? Obviously, you have not set your handlers in proper path. In that type of situation, or you don't have a mechanism to set the priorities of the handlers, or else you don't have a bypass mechanism of handlers, then that might run into performance or debugging difficulties. So we will discuss this in detail during the class. Hope you went through this simple design pattern, I would say, and then we will be able to answer these questions in the classroom. Remember, during in class test, this time we will be using few design patterns that were discussed in the previous week as well. Thank you very much. See you in the classroom.